In this video, I'm going to show you the steps that it will take to solve a linear system by elimination. Now here are 4 steps that I have just kind of before we start solving. To solve a system by elimination, you want to first start by arranging your equations with like terms in columns. And what standard form would do is make sure that all of your forms, if you have standard form, then your 2 equations would already be arranged in like terms. So you want your x's in the front, followed by the y's next, then you got your equal sign lined up, and then your constants alone on the right side. For number 2 here, it says what you'll need to do is multiply one or perhaps both equations by a number, and the reason why you're going to do that is because you want to obtain coefficients, meaning the number in front of your letter, that would be opposite signs for one of your variables. So just kind of to point out what that would look like, it would look like what you see right here, where your 5y and negative 5y will eliminate each other. So for step 3, when we add our functions together from step 2, what will happen is our y's will cancel out because 5 minus y means you have no y's left over. And so I call it big addition, but really what you're doing is just adding your 2 functions together. So it looks like this when you add your 2 functions. Your 2x plus your 6x together would give you a total of 8x's. And we needed those opposite coefficients here, like we said, obtain those opposite coefficients here, because now your y's completely cancel out. And then put your equal sign down, and now combine, add together your 17 minus 9, which is going to get you 8. And now we can solve for one of the variables. So then number 4, let's see here, solve for the remaining variable. Now what we're going to do is once we solve for x, plug it back into either equation to get the other variable. So there's kind of two steps here. Solve for one and then plug it back in, kind of like what we did with substitution. All right, so to finish here, I'm going to divide by the coefficient of 8, which I have, then my x is equal to 1. So then this is the part where I said the next step would be, which I think I didn't have here, so I'm going to put step 3.5. The variable you solved for, plug back in to either equation. Okay, so now I'm going to take my value of 1 and sub it back into one of my equations. Now it doesn't matter which equation you pick. I'm just going to pick this first one here. If I have the equation 2x plus 5y equals 17, and I substitute 1 back in, now I can solve for the other variable y. So 2 times 1 is going to be 1. 2 times 1, that's 1. Plus 5y is equal to 17. Now to solve for y, I'm going to subtract 2, and I get 5y is equal to 15. And if I divide both sides by 5, 15 divided by 5 is going to get you 3. So here would be our ordered pair, our solution to the system. It's going to be a point. It's going to be an x value of 1 and a y value of 3. So it will look like this, 1, 3. And your point there is your solution to your equation. So let's do a few more examples. I have 3 more left on this page. And what I see here is that with my variables that are aligned, I notice that my y's could cancel out if I made one of these equations negative. So I'm going to multiply the bottom equation here. I'm going to multiply everything by negative 1. So my new second function here, so that I can get these y's to cancel, my new second function will be negative 2.5x minus y equal to negative 164. And now if I combine that with my original top equation, so I'm just going to rewrite it here to combine, x plus y equals 101. If I add these together now, you'll see my y's are going to cancel out, which is why we needed to multiply by that 1. All right, so negative 2.5 plus 1 is going to be negative 1.5. My y's cancel out, and negative 164 plus 101 is going to get me negative 63. And now I'm going to divide both sides by that coefficient, negative 1.5. And I will get my solution for x here. So divide by negative 1.5, and I get an answer of 42. Okay, so now that I got my x value, I'm going to plug 42 back into either equation, and then we will solve for y. So if I use the first function, again, it doesn't matter which one, x plus y equals 101. If I sub 42 in for x, it will look like this. 42 plus a number equals 101. Subtract your 42, and you'll get your solution for your y. 101 minus 42 is going to be 59. And that number is going to go here in our ordered pair, x comma y. The point is your solution to your system. All right, we got 2 more to go. Okay, at the bottom here you'll see I have negative 2x compared to positive 7x. Now in order to get these to cancel out, I'd need to have the same number, the same coefficient, but opposite signs. So if I wanted to change these functions, I could multiply my top equation by 7 and my bottom equation by 2, and then both of those would be a 14 coefficient, one negative, one positive. But now I'm going to look at my y's here and just kind of see what I have. Positive 15y and negative 5y. If I could change the bottom one to negative 15, that would cancel without me having to multiply both equations. So I'm actually going to take that option first. Instead of multiplying both equations for the x's to cancel, I'm only going to multiply one equation to get my y's to cancel. Now if I need a coefficient of 15, and this is 5 right now, that means I need to multiply every number in my function by 3 to turn it into 15, negative 15, so it will cancel with this positive 15. So my new function here, when I multiply every number by 3, would be 7 times 3, or 21x, negative 5 times 3, which is going to give me negative 15y. This is why I wanted to cancel y's here. And then 17 times 3, which is 51. And now I'm going to rewrite that top function here. So I have negative 2x plus 15y equals negative 32. So now I'm ready to add my functions together because my y's are going to be eliminated. And it doesn't matter which variable you eliminate first. So I noticed that I eliminated y's and y's and y's again, but you could totally eliminate x's first. And actually, I'll purposely do that one on this example here to show you it doesn't matter which variable you solve for first. Now, 21x minus 2x is going to be 19x. And 51 minus 32 is going to get me 19. Oh, that's easy. Okay, divide by 19, you get x is equal to 1. So there I know x is 1. Now, if I plug 1 back into either function, I can solve for my y value. I'm going to use the bottom equation here. 7x minus 5y is equal to 17. I'm going to plug 1 in for x. 7 times 1 here is just going to be 7 minus 5y equals 17. And now I'm going to subtract my 7 over, and I get negative 5y is equal to 10. And if I divide by negative 5, I get y is equal to negative 2. So I'm going to put that value in here, negative 2. All right, last one. I had mentioned before that I had been solving for x's first because I eliminated y's. This time I'll intentionally eliminate x's first. You'll see it doesn't matter which one you do. So if I want my x's to be eliminated, I need to create a coefficient that is the same number for each of my x's, but opposite signs for the function. So one function should be a negative, and then the other function should have a positive. Now the first multiple that 4 and 3 have in common would be the number 12. And so I'm going to need to, if I want 12, I'm going to need to multiply actually both equations by a number here. My top equation, if I want to turn it into a 12, I need to multiply every number by 4. And the bottom equation, if I want to multiply to get a 12 that will cancel, I'm going to need to multiply by negative 3. And you're going to have to multiply that coefficient here into every single term of your function. So my new top of function will be, after I multiply by 4, I'll have 12x. 4 times 2 is going to give me 8y's. 4 times 1 is going to give me 4. Now my new second function is going to get me negative 12x. So that's why we were multiplying, so we could get a coefficient that will be opposite sign and cancel with each other. Negative 3 times 3 is minus 9 for the y, and negative 3 times negative 2 is positive 6 for the constant. Now, if I add my functions together, our x's are going to cancel out. I didn't put my line through these, so let me fix that one over there. Now, if I combine my y's together, I will have, let's see, negative 9 plus 8 is going to be negative 1y, and 4 plus 6 is going to get me 10. Now, I don't want negative y, I want positive y, so divide everything by negative 1, and my solution for y is negative 10. Now, just careful when you label your point, make sure you get your value in the correct spot, so I want it in the y spot of my point. Now, plug negative 10 into either function for your y value, and then you can solve for your x. Just pick one function. I'm going to pick the top one, 3x plus 2y is equal to just 1. All right, so if I plug negative 10 in for my y, it would look like this. So substitute in that negative 10. So 3x minus 20 is equal to 1. If I add 20 to the right side here, I will see that 3x is equal to 21. And if I divide by 3, I get a value of 21 divided by 3, or 7. So my solution to our system would be 7, negative 10.